Hi everyone! We're going to do another application problem that involves angles of elevation in depression. Here's that problem. Marla needs to find the height of a building. From a given point on the ground, she finds that the angle of elevation to the top of the building is 74.2 degrees. She then walks back 35 feet. From the second point, the angle of elevation to the top of the building is 51.8 degrees. Find the height of the building to the nearest foot. So from the first time we read the problem, we see that there's a person, Marla, there's a building, and we're given certain measurements. Let's read this problem one more time, but this time we're going to look at the numbers more carefully and we're going to start making a sketch. A correctly labeled sketch is crucial when solving application problems of this kind. So Marla needs to find the height of a building. So here's the building and here's Marla. Here's the segment representing the height of a building. Let's continue reading. From a given point on the ground, she finds that the angle of elevation to the top of the building is 74.2 degrees. So first of all, here's the ground. Let's assume that from the point where she's standing, from that point on the ground, she finds the angle of elevation to the top of the building is 74.2 units. So what would be the angle of elevation? Remember, it's always between the horizontal segment or ray and then segment that goes upwards, like that. So the angle of elevation is here, and it's given to be 74.2 degrees. Let's continue reading. She then walks back 35 feet. So she moves away from the building, and now Marla is here. It's given that she walks back 35 feet. So the segment is 35 feet. And from the second point, the angle of elevation to the top of the building is 51.8 degrees. Well, we already figured out how the angle of elevation is going to be positioned. So the second angle of elevation is this one here. It's 51.8 degrees. Well, looks like we labeled everything we were given. Now let's start thinking how to approach this problem. First of all, we can recognize that this angle here is the right angle. It's formed by the height of the building, which is perpendicular to the ground. Let's also add some letters so it's easier to refer to different segments and angles. Let's say that the right angle we're going to label C. At the top of the building we're going to place A. Let's put B down here and D over here. So the length that we need to find, H, is the side on triangle ABC. Well, and also it's the side on triangle ADC. Both are right triangle. This is the smaller right triangle and that's the bigger right triangle. But remember that to solve the right triangle, in other words, to find any unknown angle or any unknown side, we have to know at least one side. And as I look at these two triangles, ABC and triangle ADC, I realize that I don't know the length of any side. Well, we know that this segment is 35 feet, but it's not representing a side of a right triangle. So what do? We have no choice but introduce another variable. Let's do variable x, and we're going to label this segment by x. Why do we have to do this? Well, because even though x is unknown, now we have something to represent side of a right triangle. In a small triangle ABC, now we have one side labeled as x, and in the bigger triangle ADC, we have side labeled by x plus 35. And next we're going to do the following. First, we're going to look at the smaller right triangle. And we're going to try to express the height of the buildings, something that we essentially need to find. Well, for that we're going to use the right triangle trigonometry. If we look at the given angle, then the sides that we, don't know yet, but at least we have them labeled, are the opposite side, which is h, and the adjacent side, which is x. Now, what function involves the opposite and adjacent sides? It's tangent. So I'm going to say the following. From triangle ABC, we get this. Tangent of angle 74.2 degrees equals the opposite side, which is h, over the adjacent side, which is x. And now if I want to get h by itself, I'll need to multiply by x on the right. I want to cancel the denominator, and I need to multiply by x on the left. So h equals x times tangent of 74.2 degrees. Now we have to continue because, well, we're not able to find h yet. We don't know what x is. So we're going to repeat these steps, but for the bigger right triangle. This one, triangle ADC. In this triangle, we know one angle, 51.8. Well, h is its opposite side, and its adjacent side is x plus 35. Again, we have opposite side, we have adjacent side. We're going to use the tangent function to relate all of them. So from triangle ADC, this is what we get. Tangent of 51.8 degree angle equals the opposite side, which is h, over the adjacent side, which is x plus 35. And I'm going to repeat the steps by solving for h. For that, I need to clear the fraction on the right-hand side, so I'm going to multiply by its denominator. X plus 35 on the right-hand side, that will cancel the denominator. And I need to multiply by same thing on the left, x plus 35. This means that h equals x plus 35 tangent of 51.8 degrees. Again, we're not able to find h just from that equation because we don't know x. But this is what we're going to do next. We know that h equals x times tangent of 74.2 degrees, and we know that h equals this expression, x plus 35 times tangent of 51.8. Well, since they're both equal to the same quantity, which is h, that means that they're equal to each other. So those two are equal to each other, and it means that we can set them equal. So x tangent of 74.2 degrees equals x plus 35 tangent of 51.8 degrees. And this equation will allow us to find x. And once we know x, we can use either one of those two equations to find h, the height of the building. Well, we're going to go with the first one, right? It's going to be a little bit quicker since it's a simpler equation. But how do we find x? How do we solve this equation? It's actually just a linear equation. It doesn't look too pretty, but it is just linear equations. So this is what we'll have to do. First, we're going to distribute tangent of 51.8. So we'll get x tangent 74.2 equals, then it's going to be x tangent of 51.8 plus 35 tangent of 51.8 degrees. Next, we're going to combine all terms, and here we have three terms, one on the left and two on the right. So we're going to combine all terms involving x on one side. That means that I'll need to subtract x tangent 51.8 as I subtract it on the right. This term gets cancelled, and then I will subtract it on the left. So I'm going to continue with the scratch work here on the top, and then we'll go back to our original equations. So far on the left we have x tangent of 74.2 degrees minus x tangent 51.8 degrees. That's the left side. And on the right hand side we only have 35 tangent of 51.8 degrees. We're almost there. So what we'll do next is the following. Notice that on the left we have two terms and they both involve same factor, which is x. That means that we can factor it out. So let's factor out x. As I pull out x, I will have tangent of 74.2 degrees minus tangent of 51.8 degrees left. And then on the right hand side is 35 tangent of 51.8. Now be careful here, there is no easy way to simplify this expression, so there is no combining like terms or anything like that. So we're going to leave it like that as the difference. And we're trying to find x. So what I'll do in the next step is I'm going to isolate x by dividing the left hand side by this difference and the right hand side by that difference. Like that. Well, on the left hand side, that cancels the difference, and I'm left with the following expression. X equals 35 tangent of 51.8 degrees over, and the difference in the denominator, tangent of 74.2 degrees minus tangent of 51.8 degrees, like that. So what we have here is actually the value of x. Yes, it doesn't look pretty, and yes, pretty soon we're going to put this all in the calculator and approximate this value, but that is the value of x. Notice there are no variables on the right hand side, only the numbers. Well, I'm not going to evaluate it yet because I want my final answer to be as accurate as possible, so I am trying to avoid any rounding as I go. What I'll do, I'll take this value and I come back to where I started. Remember, we need to find h, and we said how that was the perfect equation to use to find h once we know x, because now we simply need to plug in x over here, multiply it by tangent of 74.2, and we find h. So let's do that. By the way, using the second equation is also fine. It just has this extra step, so that's why we're not gonna use it. Okay, so h equals, I have to take x. That's what we just found x equals to. And it has to be multiplied by tangent of 74.2 degrees. Well, let's try to approximate this expression. If it's possible for you to input the entire expression in your calculator, that's the best way to go to get the most accurate result. If not, well, then you can just evaluate this expression piece by piece, right? You can evaluate each tangent separately and then put the whole numbers together, in this expression. I'll try to input it as one expression. I'm going to start by typing the numerator. So it's 35 tangent, then it's 51.8 degrees, and I know that I am entering degrees because it shows little d here on the top. It's very important that you have the right units set up on your calculator. Otherwise, answer is going to be incorrect. Then I have to divide. Now, in the denominator, I have a difference. It's going to be very important to put that difference inside the parentheses. Otherwise, the order of operations is not going to be preserved. So I'm opening parentheses, then I start typing tangent of 74.2 degrees. I close parentheses 4 degrees. Then I subtract another tangent of 51.8 degrees. I close parentheses for the degrees, and now I close parentheses for the denominator. And then all that has to be multiplied by tangent of 74.2 degrees. And that's what I got. That is the value of h. Now in the problem it says find the height of the building to the nearest foot. So I'm only keeping the whole part. Since the first digit after the decimal point is 4, it means that I will be rounding down. So it's just 69. That's what I'll write. So the height of the building is approximately, well, because we had to round, 69 feet. And because it's an application problem, I'm going to write down answer using a sentence. Okay, so I wrote that the height of the building is 69 feet. So that's how you solve this kind of problem where you have to introduce additional variable, and that happens when you don't have enough information on the triangle to solve it.